Hello students. In this session, we will take up the topic thermochemistry in physical chemistry, and the focus is on Born-Haber cycle. But before we do that, please hit the like button and subscribe to my channel. Let's do a quick recollection about the importance or significance of Born-Haber cycle. Now, Born-Haber cycle is used to determine the lattice enthalpy of pure ionic compounds, of pure ionic compounds. Now, what do we mean by pure ionic compounds? The ionic bond should have a difference in electronegativity greater than 1.7 or 1.8. Okay, some ionic compounds show covalent characteristics. So that will result in a difference in their lattice enthalpy values when experimentally determined. Coming back to Born-Haber cycle involves a lot of thermodynamic terms. It is an energy cycle constructed with a lot of thermodynamic information. All right. So solving this question will also help you to recollect the various thermodynamic terms that you have come across, like enthalpy of formation, ionization and energy, bond enthalpy, electron affinity, etc. So now let's go to the question. Here is the question. Calculate the lattice enthalpy of this ionic compound, calcium carbide, solid calcium carbide, from the following thermodynamic data. So you're provided with enthalpy of formation of calcium carbide solid, enthalpy of sublimation of solid calcium and solid carbon, right? The first and second ionization energies of gaseous calcium atom. You're also provided with something very, very interesting, which makes this question also very interesting, which is the bond enthalpy of C2 gas. Apart from that, you're provided with information regarding the first and second electron affinities of gaseous C2. Okay, so these are the various thermodynamic terms involved here, which we will discuss in detail. So as I construct the Born-Haber cycle or the enthalpy cycle, each thermodynamic term will be recollected in terms of the definition. All right. And the question here is to determine the lattice enthalpy of this particular ionic compound. Before we construct the energy cycle, let's understand what is the formula or the constitution of calcium carbide. The formula is CaC2. Okay. What is the structure? The structure is an ionic compound where calcium is bonded to two atoms of carbon. The two atoms of carbon are held by a triple bond, and you have this structure. This is calcium carbide, and calcium carbide is made up of these ions, Ca2 plus and C2 2 minus ions. These are the ions involved in the formation of calcium carbide. It is important that you be prepared with the identity of the ions before you start constructing the cycle. Okay, now let's construct the cycle. To construct the cycle, we start with the first information provided, which is the enthalpy of formation. How do you define enthalpy of formation, or what do you understand by enthalpy of formation? It is the enthalpy change when 1 mole of a compound under standard conditions. Okay, here the compound is calcium carbide. The physical state is the solid state under standard conditions, temperature being 25 degrees Celsius, from its constituent elements. The elements are calcium and 2 atoms of carbon, also in their standard states. So the physical states have to be represented in the Born-Haber cycle. Okay, so this is the first transformation, which is the formation of calcium carbide from its constituent elements, and we call this enthalpy change as enthalpy of formation of calcium carbide, which is exothermic. And what is the value? Minus 60 kilojoules per mole. The next conversion, the next thermodynamic term is the conversion of solid calcium to gaseous calcium. Okay, solid calcium to gaseous calcium. Now, this is what we call as the enthalpy of sublimation of calcium solid. We also call it as the atomization enthalpy. And it is an endothermic process, right? And what is the value? Plus 179 kilojoules per mole. The next transformation is these two solid calcium atoms are also converted to two gaseous carbon atoms, and that enthalpy term is also the enthalpy of sublimation of carbon solid. But here enthalpy corresponds to the formation of, or enthalpy corresponds to 1 mole. Here 2 moles of gaseous carbon atoms are formed, so it should be 2 into. All right. And what is the value given here? There also is endothermic, which is 718. So this will be 2 into 718. Okay. So once we are done with converting the solid atoms to gaseous atoms, next step involves the formation of ions. Gaseous calcium will lose, gaseous calcium atom will lose 2 electrons, not in one step, one after the other, right? And 2 different energies are absorbed, and that energy is called the ionization energy. So we have 2 successive ionization energies. This is IE1 and this is IE2, which involves, so when the gaseous calcium atom loses 1 electron, it forms Ca1 plus gaseous, and we call it as the first ionization energy. Ca1 plus gaseous will lose 1 more electron to form Ca2 plus gaseous, and we call it as the second ionization energy, right? And the first ionization energy is lesser than the second ionization energy, because the removal of the second electron requires a larger amount of energy to be absorbed, because electron is removed from a cation, from a positive ion, right? The second electron is removed from a positive ion. So greater effective nuclear charge, right? So that is about the first and the second ionization energies. Coming back to the cycle, here we will write both in one step. Ca2 plus gaseous losing 2 electrons, and this transformation corresponds to the sum of the first and the second ionization energies. What are the values? 590 and 1143. So 590 plus 1143. Okay. Now comes the interesting aspect. Let me go back to this board. We have got 2 gaseous carbon atoms. These 2 gaseous carbon atoms will combine to form 1 mole of a covalent bond in C2 gaseous molecule. So this involves another thermodynamic term called the bond energy or bond enthalpy. I'm sure you are able to recollect this. Correct? Now this involves formation of C2 from the 2 moles of gaseous carbon atoms, and formation is always exothermic, right? So here we have, next step would be the combination of the 2 gaseous carbon atoms to give you C2 gaseous. That energy involved is the bond energy of C2 gaseous, and this is exothermic. So value given here is 614. So if you make a mistake and write 614 as the value in the conversion of 2 gaseous carbon atoms to C2 gaseous, you will go wrong in the calculation. So you've got to understand that this is exothermic, and therefore it is minus 640. Okay. Our next step is to add 2 electrons in 2 different steps to C2 gaseous atom, right? So when 1 electron is added to the C2 gaseous, when 1 electron is added, we get C2 1 minus gaseous ion, and this happens to be exothermic. Now C2 1 minus gaseous ion, when it gains 1 more electron because of repulsion, this electron is not held strongly in the or firmly in the valence shell. Energy has to be absorbed. Because of that, the formation of C22 minus gaseous would be endothermic, as stated in this list. This is EA1, the first electron affinity, which is exothermic, and the second electron affinity, which is endothermic. All right. So you have EA1 and EA2. So these are the two equations involved in the formation of C22 minus gaseous. Where do those two electrons come from? Those two electrons are already made available during the loss of electrons from gaseous calcium atom to form gaseous calcium ion. Right? So here again, this will be shown as one step where you get C2, where you get C2, 2 minus gaseous. It occurs in two steps, EA1 plus EA2. EA1, EA1 plus EA2, and the values are minus 315 plus 410, right? Minus 315 and plus 410. Okay, so now we finally have arrived at the two ions that were required to determine the lattice enthalpy. Okay, which is Ca2 plus gaseous ions. We have made a note of the two ions present in calcium carbide, calcium ion and C22 minus. We have arrived at both these ions in the gaseous state. Now comes the last thermodynamic term, which involves the combination of these two gaseous ions to form 1 mole of this ionic compound, and that happens to be, or that is nothing but the lattice enthalpy of the ionic compound solid calcium carbide. Okay, fine. So these are the various enthalpy terms or thermodynamic terms, and your task is to find out the lattice enthalpy of calcium carbide. Now let's compile all the vectors or arrow marks or directions in the clockwise direction and in the anti-clockwise direction. And you will notice that only this vector is in the clockwise direction. All the other vectors are in the anti-clockwise direction. Okay, so let's compile all the values. So only enthalpy of formation is in the clockwise direction. All the others, what are they? Let me list all the other thermodynamic terms. Sublimation of calcium solid plus 2 into, don't forget all this, enthalpy of sublimation of carbon solid plus, after that what do we have? We have the ionization enthalpies, the sum of the two ionization enthalpies, and then we have the sum of the two electron affinities. But before that, we have the bond enthalpy or the bond energy of C2 gaseous plus the sum of the two electron affinities, and finally lattice enthalpy of calcium carbide. Right? Now let's place the values. What are the various values? The values are minus 60 is the value for enthalpy of formation, that is equal to sublimation. We have written all the values here. Sublimation of calcium is 179 plus 2 into sublimation of carbon is 718. 2 into 718. The two ionization enthalpies 590 plus 1143. Then plus coming to the bond enthalpy of C2 gas, which is minus 614. So that is one area where you are likely to make a mistake. So be very alert about that. Plus the sum of the two electron affinities minus 315 plus 410, and finally what we have to determine, which is the lattice enthalpy. So what is lattice enthalpy equal to? Lattice enthalpy will therefore be equal to minus 60 minus 179 minus, what is this? 2 8s are 16. You have 3 14. So this is 1436 minus, what about this? 3 3 7 1. The two ionization enthalpies 1733. Okay, so 1733 minus 614, and this would be plus 95, plus 95. And if you solve for this, you'll get the answer as minus 2889 kilojoules per mole. Okay, so this is the answer to the question, or this is the value that we get for the lattice enthalpy of solid ionic compound calcium carbide. All right, so by solving this question, I hope you've been able to recollect all these important thermodynamic terms: formation, enthalpy of sublimation, first and second ionization energy, first and second electron affinity, and an interesting aspect of this question, namely the bond enthalpy of gaseous C2. All right, and you also would have been able to recollect how to construct the Born-Haber cycle and arrive at the final answer. Thank you.